Thank you, thank you. Can you hear me okay? Can you hear me at all? Yes, oh, very good. Well, thanks for braving the rain. You know, I was on my way over here, I'm stepping out the door, and this huge, huge black cloud comes overhead, dumps rain out. It's like, well, that's going to cut attendance in half. So thanks for braving the elements. So we've got an hour here to chat. I'd like to talk about a couple things of interest to me. I hope they'll be of interest to you. First of all, we talk about programming, we talk about software development. What is programming? That's a seemingly easy question, but I find every year goes by, it's a little bit harder to answer. So I try to go for a kind of more generic approach. It's problem solving. What we do as programmers is solve problems. We happen to write software to do it or use software to do it, but for the most part, we're sitting around trying to solve problems. Well, that's kind of cool. That sounds like something fun. But the problem is, in order to do that, you need ideas, preferably good ideas. You need to have solutions. You need to come up with stuff. You know, how are we going to do this? How are we going to fix this? How can we build unicorn apocalypse? How can we build, you know, whatever? You got to come up with this inventive stuff all the time. And you've got to learn all the time. I guarantee you, every technology you're learning right now will be completely obsolete in 5 years, will be a footnote in history in 10. No one will even have heard of it. That's how fast things move. So we're learning all the time, and we've got to come up with stuff. We have to invent things all the time. So tonight's talk, I want to talk about three things. I want to talk a little bit about how your brain works, when it works. And I want to go over a deceptively simple technique for producing ideas. It's a 5-step technique. You go through the steps, and I guarantee you it will generate ideas. They may not be wonderful ideas, but you got to start somewhere. So we're going to talk about a technique for actually producing ideas. And then real briefly at the end, I just want to talk a little bit about how that ties in to modern software development and the remains of the Agile movement and that sort of thing. So to start off with, let's take a look at how your brain works. For years, the neuroscientists and such taught that once you reached adulthood, your brain had a fixed number of neurons. You grew to some magic limit, and that was it. You would get no more. If you wanted to learn more stuff and you had filled up already, well, tough. You were out of room. Your drive was full. That was it. If you lost neurons due to, say, beer consumption, you wouldn't get any more back. That was a permanent loss, they thought. Fortunately, as it turns out, that's not true. You do grow new neurons all the time, or at least you can. And what happened was the original study that they did on primates was flawed. When they did this study, they took the subject animals and put them in a sterile lab cage to study them in the lab. So here's this poor animal with gray walls, with nothing to do, almost like a prison cell, with kind of like that, with no sensory input at all. And yes, under those circumstances, you do not grow new neurons, because there's no need to. Your brain's not stupid for the most part. It's very conscious of resource allocation. It doesn't need them in this case. Now, if you're in a sensory-rich environment, like the primate's jungle habitat, where you've got all the predators and jungle sounds and things falling out of trees at you and whatnot, that's a different story. In a sensory-rich environment, you do grow new neurons, which is kind of interesting. So first of all, what that tells us is that you can, in fact, rewire your brain. Because when we talk about learning something or having a thought, you have to realize that the analogy of software running on hardware is not correct. When you're thinking a thought or making a memory, it's not just that some new circuit's being made and currents running through it. You're actually building new wires. You're actually building new structures in the brain, chemically and physically, when you learn something, when you have a thought, when you memorize something, when you have a flash of insight. You know, thoughts are ultimately physical in the brain. So the first thing we want to learn from this monkey study was that you can rewire your brain physically, right? Taxi drivers in London have a huge percent of the brain devoted to a map of London that I don't have. You know, piano players have portions of cortical real estate devoted to scales. I keep trying to have some of that. It's not working out so good. But you can rewire your brain. And the second thing just to keep in mind is that context matters. The reason this study was flawed and people thought the wrong thing for decades was because they studied the animal outside of its native habitat, outside of the appropriate context. And oftentimes, all it takes to get an insight, to learn better about something, is to just look at it a slightly different way. So for instance, an axe is a wonderful tool. I've used it to chop down trees, chop firewood, whatnot, but you probably wouldn't want to go hitchhiking with one. The context is off. That might just send the wrong message. You've probably at some point in your academic career had to make a solar system model, right? Everyone's had to make a solar system model with little balls of styrofoam and, you know, things go around, right? And interestingly, as models go, it's correct, but it's not really accurate. You know, forgetting issues of scale and whatnot, it conveys the impression that you've got the sun here and the planets are going around it and that it's a fairly static situation. So the Earth is here this January, next January we're coming right back to the same old spot. Well, that's not really true, right? Because the whole solar system is in fact whipping through the cosmos. So a better model might be a vortex. It's still the same thing. You're still looking at planets whipping around the sun, but the whole thing is whipping around through the cosmos. So we're going places. I don't know where exactly, but we're going places just by looking at it a slightly different way. So that's what I'd like to accomplish tonight, is to get you to think about the brain and learning and insight just a little differently. So here is a low-res picture of a brain. The green-colored areas there is made up of a bunch of different discrete regions of the brain that form the executive attention network, or what I tend to call linear mode. This is the part of the brain, a network of areas of the brain that comes to bear when you're focused on a task. You know, you're reading, you're paying attention to something, you're focused on something. That's the EAN, executive attention network. The red areas is about 10 different other regions that make up the default mode network. Default in the sense that that's like an idle loop. That runs when you're not focused on something. It's sort of like a set of background processes, if you will. So one way to think of this, if you look at these two different networks operating in the brain, think of them sort of as like CPU models, right? You've got this, the executive attention network is kind of like a traditional Van Neumann processor. It handles one instruction after another. You know, this again is what you're focused on. It's fairly slow, operates about the speed of speech, about 110 BPS, more or less. But it's familiar. We're used to using that. Then you've got this other CPU mode, the default mode network, and some of the associated networks that don't act like that. They're non-linear. They're asynchronous. If I pose a trivia question to you and you don't remember it offhand, but like the next day, you know, in the shower or walking to class, it pops in your head, that's these mechanisms over here. They're asynchronous. So they're chugging along in the background, and when something comes up, it pops out at you. Interestingly, verbal abilities tend to be concentrated over there, and visual abilities tend to be over here. And we'll get to why that might be important in just a second. So this linear mode, what was originally called back in the 60s sort of like your left brain attributes, which turned out to be wrong. It's not strictly hemispherically divided. It's these interlocking networks that do it. But you've got this set of thought processes that tend to be associated with this style of thinking, very verbal, very symbolic, that sort of thing. Then you've got this rich mode processes that are nonverbal. non-rational, intuitive, synthetic, learning things by putting things together instead of dissecting them and taking them apart. Now, the nonverbal part is interesting. It turns out you've got a lot of cognitive ability that is not dependent on verbalization. For instance, you can recognize something like 1,000 different faces despite all kinds of distortion. You can meet a friend 20 years from now that you haven't seen and recognize them because that kind of visual discrimination is really well done. But try to describe one face to a police sketch artist or something like that, it's very, very difficult. So you can have these great thoughts, but they're not necessarily verbalizable. These processes also work as sort of like a search engine. Like I mentioned with the trivia question, if you're trying to come up with something, these will find it. But because it's asynchronous, you don't necessarily know when that thought's going to pop out at you. And we're going to see something about that in just a moment. But first, let me ask you all a question. How many of you here are software programmers, software developers? You do that kind of stuff. You're studying that. That's why you're here. You can go ahead, wake up. That's it. That's it. Okay, great. Now, raise your hand if you are a really good artist. You draw pencil, pencil sketches, pen and ink and paint, and you hang it. And don't be shy. Come on. Okay, all three of them raise their hands. Good. Yeah, that's very, very typical. In fact, yay on you three. That's more than I usually get in a crowd this size. Typically, those of us in the sort of technical fields really suck at drawing. We're just not good at it. And the reason for that is our sort of L mode abilities are so honed and so strong that they crowd out the R mode processes. The two are somewhat mutually exclusive. It's like they've got a shared bus. And when one's active, the other one is dormant, and they take turns. So the problem with having an active L mode is if I asked you, for instance, to draw your house, say, right, you would probably draw something like this. I did that. I'm so proud. So what happens is your L mode processes in the brain say, house, I know that one. It's a box with a triangle on top of it. And this is a form of data compression that your brain does. If it didn't do that, your brain would be overwhelmed with sensory input. So many of the things you look at get reduced to a symbol for ease of processing, right? So a house isn't all these shades and tones and shadows and little details. It's a box with a triangle on it. And this is why we can't draw. Because when we go to see something, our L mode says, oh, don't be stupid, it's a box. And move on, and that's what we get. So one of the tricks, if you want to learn how to draw, is in how to quiet the L mode and let the R mode actually perceive the details you're trying to capture. The problem with drawing isn't drawing, it's seeing, which I thought was kind of interesting. But irrelevant. We're moving on. So what I want to look at here is a 5-step process for producing ideas that relies on this notion of background asynchronous processes in your brain that we want to try to tap and use better. So here's the 5 steps. Step 1, gather the raw material. Okay, there's a particular way we want to work with it once we gather it, and we'll look at that. Work with the material. Again, there's tricks. Step 3, the most important step of all, forget the whole thing. Step 4, you get your Eureka moment, which is more often, my, that's peculiar. Step 5, refine and develop it, blah, blah, blah. And of course, step 6, profit. So let's take a look at this. Step 1, gather the raw material. Jerry Weinberg has a book, I forgot what the name of that particular one was, he's written a lot of books, where he talks about the writing process, gathering research for writing an article or a book, as gathering fieldstones. The idea being you're going out and gathering these chunks of knowledge, these little gems of knowledge, but you don't really know how you're going to use them yet. So you kind of make a big pile, just like you're building a dry rock wall without mortar kind of thing. You gather a bunch of stones up, and as you're building the wall, right, you get to a certain spot. Okay, I need a flat edge, and it needs to be about this big. And you go through the field stones, and this looks about right. This fits here. This one will fit there. So the idea is, you go through and gather all these raw mental field stones, facts that you get from reading, from research, from the internet, wherever, insights that you get from, we'll get to that in a second, and questions that you have. It's like, well, why hasn't someone invented this yet? This seems obvious. Why aren't these two things related? Questions that come up. So you gather the raw material up. Now, for factual matter, that's fairly straightforward, although there are some neat tricks to it. If you're going to read a book or take a course or some long-form work like that, you can just read it and take notes in the sort of usual way. But if you throw just a little bit of discipline on top of that, you can get better results. And there's several different methods kind of in this family. This one's called SQ3R, very cleverly named because the steps are an S, a Q, and 3 R's. But they're all kind of roughly the same. And the idea is you start off by surveying the work. So by that, if it's a book, say, you scan the table of contents, look at the chapter summaries, kind of get your head around the whole thing before you jump in. And this has the advantage of sort of prepping neural pathways, if you will, when you go to read it later. You kind of have a framework already to hang it on. Note any questions that you have that you hope this is going to answer. Is this going to show me how to do stack unwinding, nested exceptions, blah, blah, something or other. Write down your questions. And then you read it through in the entirety like normal. And then recall it, try to quiz yourself. If you haven't figured out yet, the best way to study is to quiz yourself, not to reread the material. It's the act of retrieval that strengthens the memory connections, not the act of re-inputting them again and again. So quizzing yourself, the most powerful technique there. And then review it, go over the notes, talk it over with people, that sort of thing. So that's a great way to get facts chunked in. Then for insights, for flashes of invention, flashes of creativity, we want to try to have easier access to those R mode processes, those default mode network processes in the brain. And it turns out it's easiest to do that when you're in a hypnagogic or hypnopompic state, which are wonderfully Latin words, meaning you're just about to fall asleep or you're just about to wake up. Isn't that great? All that packed into that one little word. And there's a couple great case stories of this in history from famous inventors. The first one here from one Elias Howe, who in 1845 invented the sewing machine, or at least a critical portion of the sewing machine that he got a patent on. And so old Elias was there trying to get this sewing machine thing to work, and it wasn't going very well for him. He was not having success at getting the lock-stitch mechanism to function. So one night, he has this horrific nightmare. I think it involved pepperoni pizza and beer or something horrible. He wakes up this horrible nightmare, and he's being chased by headhunters through the jungle. Jungle headhunters with spears, not the other kind of headhunters. That'd be scarier. So he's got these jungle headhunters chasing him with these big spears, and he's describing the dream and saying, they look like regular spears, they're all pointy and stuff, but up at the point there was a hole in the spear, almost like you could pass a thread through it. And that was his eureka moment. The big difference, it turns out, with a machine sewing needle is you've got to put the hole up at the pokey part, not down at the back end. On a hand sewing needle, the hole for the thread is at the back end. The big difference here is you put the hole up on the sharp end. So he knew this, or at least somewhere in his mental processes, he had figured out that that was the answer, but those parts of the brain that had concocted this answer weren't able to access the verbalization centers to present it to him. So what happens? You get this vivid, rich imagery that comes to you in a dream to suggest the answer that you're looking for. Wow, that's kind of interesting. So could we do something like that? Yeah. Simply you can do a version of targeted daydreaming, right? You sit with your feet up and stare at the clouds, pose yourself a question and close your eyes, and things will flit past your screen of consciousness. And you want to kind of hang on to them. You want to solidify that very fleeting kind of thought that goes by. So there's tricks to that. You describe each image out loud. So now you're sitting with your feet up, your eyes closed, and you're talking to yourself. Might want to not do this in public. You try to imagine it with all senses. And this is one of those things where, describing it out loud actually activates different neural pathways than just forming the words in your head, which isn't enough. You need to actually do it out loud. You try to imagine it with all 5 senses. You describe it to yourself in present tense, which actually tricks the brain into bringing the image back if it already filed it away. It's like, oh crap, that's supposed to still be there, whoop, and brings it back out. And like I said, you can sit and stare at clouds and do this. I did this the other day, and I swear the clouds looked like they were spelling something. It could have been my imagination. So a slightly less woo-woo way of doing this is a technique that's taught in writer workshops and executive retreats, some MBA courses, a technique called morning pages. And what you do is you wake up first thing in the morning or afternoon, whenever it might be, and you write out 3 pages longhand text of whatever crazy thing is on your mind. Because again, you're in that hypnopompic or hypnagogic, I forget which way it goes, you're in that half-awake state where you've got access to the R mode networks in the brain, and you have a greater chance of something interesting popping out without having to wait for the scary nightmare with the headhunters and the spears chasing you. This is a slightly better way to try to access that level of material. And this one was kind of interesting when I read a case study about it. They were teaching this at one executive retreat, and this one guy who was head of some, Fortune 50 big stuffed shirt suit kind of company, he's like, I paid money for this course, and you guys want me to like scribble first thing in the morning before I've had my coffee? Are you kidding me? Very, very not on board with it at all. But tried it for a week or two, and after about 2 weeks, 3 weeks, he noticed he was getting product ideas, marketing plans, solutions, things he was working on were starting to just kind of like fall out of his head onto the paper. And he became a great convert to the practice. So that's one thing you can do. Tom Edison, prolific inventor, had a unique take on this. He realized this advantage of that kind of twilight of consciousness and harvesting ideas from it. So he'd be stuck on a hard problem, and he'd go to take a nap in his study, or living room, wherever he was there. But he'd sit down for a nap in his easy chair, holding a cup of ball bearings. All right? And so as he starts to fall asleep, bang, 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 clatter, 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 it wakes him up, and he quickly jots down whatever was on his head. This worked great for him, he claimed. I can't imagine his housekeeper was too enthused about the whole affair, but he claimed it worked wonders. So, and it's kind of interesting that that would work, because what this actually means for us is that the best ideas from these asynchronous processes in the brain are going to come to you when you're least able to sort of deal with it. You're not going to be sitting in front of the computer. You're going to be mowing the yard, doing the dishes, taking a shower, having some quality hammock time, something like that. And in fact, it turns out if you're stuck on a problem, the worst place in the world you can be is in front of your computer. Because when you're sitting there typing, you're activating all those linear L-mode processes that are involved in symbol manipulation. And you're choking out the other processes that you want to access for a creative idea. So when you're stuck at a problem, the best thing to do is stand up and walk away from the keyboard. And if you talk to programmers, this happens all the time. You're stuck on a bug, you can't find it, you can't fix it. You're about to smash the bloody computer through the wall. You get up, walk away in disgust. You're halfway down the hall, halfway out the building, and the idea pops to you in your head. Oh, I didn't check. Did I set X to 0? Whatever it was. You go back. It's always X, right? You go back, you fix your thing, and bang. Happens all the time. Very, very common. So we have a bit of a problem there. We're going to get these ideas when we're not really equipped to deal with them. And you might think, well, that's okay. It's, this flash of insight is going to come to me. It's going to be great. I'll remember it. I'll go back to my room. I'll go back to my office. I'll jot it down. It'll be great. No, you won't. You'll forget it. Human memory sucks. I've got a whole 90-minute spiel on just how and why and how badly your memory sucks. Do not rely on it. It's a horrible, horrible thing. So this presents another problem. If you don't make a big deal of getting a good idea, your brain will give up and stop giving them to you. It is a complex adaptive machine. It is self-modifying. If it gives you all these great ideas and you don't do anything with them, some mechanism says, oh, well, we're not using that stuff. Jettison it like last night's physics homework. It's gone, right? Won't do it. So you have to actually capture good ideas when you have them. And it turns out everybody has great ideas, believe it or not, but very few bother to keep track of them in any systemic way, and then fewer actually act on it. So the first thing you gotta do is have something with you 24/7 that you can capture good ideas on. I like to use either a Moleskine notebook, either the big size or one of the little tiny ones, and I always carry my Fisher Space Pen with me, right? These things are great. This will write upside down in a boiling toilet if you ever have the need. I haven't tried that exactly, but you have it with you all the time. And it can be anything. It can be pen and paper. It can be a set of index cards. You can use your mobile phone or your iThingy. If you're stuck in traffic and driving, I tell folks with long commutes to do this. Leave yourself a voicemail message, and if you've got, a lot of these voicemail technologies will transcribe it and email you text of your voicemail messages. So I call and leave myself a voicemail message, and when I get back to where I'm headed, I've got an email saying that I got voicemail with my message transcribed, and I can copy and paste it and stick it in whatever I'm working on. But you want something with you 24/7 that you can capture it with. Now, if you're a starving college student, not that anyone's here starving, but there's this really fun site called pocketmod.com. And they've got this clever little thing where you print out a single sheet of 8.5 by 11 paper, and with a couple scissor cuts and a little golf pencil, you've got a little 8-page notebook that you can stick in your pocket. It's waterproof. It doesn't need batteries. You can use it before takeoff and landing. It'll go through a metal detector. It's genius. But something with you all the time, because these are asynchronous processes, you don't know when the good idea is going to hit you, and you got to be sure to capture it. So, okay, dynamite. We've captured it. We've got that sucker. Now what do we do with it? Well, now we need to work. We need to work these raw materials and work with them to generate insights and ideas. And the most important thing about working with these fragile notions is you don't want to multitask. Some people are really into serious multitasking. Not recommended. Again, I've got a whole spiel on how multitasking is horrific for your brain. The short answer is if you're interrupting your task by something else, it can take 30 to 45 minutes to reload task context to get back to what you were doing. That can kill your day pretty quick. And if you're working with these very, very fragile idea thoughts, that's deadly. Not going to happen. So you want to somehow arrange for being deliberately creative. Someplace that's isolated in time and space. And there's a great video on this by none other than John Cleese of Monty Python fame, where he talks about the creative process. And he's very clear that you have to have some place outside the stream of normal life. You know, take an hour. It can be at the park. It could be in some room somewhere. It can be in your room. But someplace where you're not going to get interrupted, that you can work with the ideas you're working with. So what do we do? Well, as it turns out, I was always a big doodler. I loved to doodle. I'd be sitting there in a lecture hall and I'd have all kinds of spaceships and rockets and, unseemly things all over the page. That's how I take notes, right? Works for me. They're crude. I mean, this is not art, don't misunderstand. But it's a great way to tap these kinds of mental processes. So we want to use what's called a mind map. Very simple idea. You start in the center of the page-ish with your topic, and then you start branching off to major topics out of that, and then things that you learn from there. And this is very much an exploratory process. So as you learn things, you're going to start squishing them in and filling in stuff and realize that, oh, this is actually related to that, which is related to this. You can draw big swoopy arrows around it. You do not want to do this in a computerized tool necessarily, because again, you don't want to get that kind of symbolic reduction trap. You want something hand-drawn and very flexible as you work with them. So as you get your facts, your insights, whatever, you splash them onto your mind map. And then to work with it, you ask yourself questions about it. How are these things related? Are they related? What else do I know? What else can I put on there? I'm done. I took the course, I read the book, I got a bunch of stuff on my mind map, I'm done. What else can you put on there? That's where working it comes in. And again, hand-drawn, right? Drawing engages this rich mode and helps work the other way to suppress the symbolic reduction of linear mode. Large and fine motor functions as you're drawing engages more brain hardware. Adding colors and textures increase brain activity. And they've shown that when you're trying to remember or memorize something, the more sensory input that's associated with it, the stronger those neural connections will be. Hand-drawn, there's always room to squish in something. This is fascinating. So you go through, you draw the thing, and say, all right, I want to tart this up a little bit. I want to add color to it. I got a nice set of colored pencils from the bookstore. I'm going to go through and add color to my mind map. Well, that sounds like it's just a sort of decorative activity, but it's not. What you're actually doing is saying, how can I categorize these things? What kind of ontology, what kind of taxonomy, what kind of hierarchy might be imposed with these things? So you're actually forcing yourself to sort of look at the relationships between these items much more deeply. And as you're doing that, probably the most important part of this activity is to play freely with the ideas. And this we're not very good at as a society. It's okay to fail. It's okay to try to squish two things together that's not going to work. For this exercise, that's fine. So we actually want to cultivate abnormal thinking. Right? Normal thinking at this stage is to be right, to be correct at every stage. But we're trying to come up with new stuff. So we want occasionally deliberately crazy connections. Try to add things together that make no sense. We need to allow intermediate results that are impossible. Well, that couldn't really work in the real world, but if it did, and use that as a seed to generate ideas. So for example, suppose, again, coding example, you're trying to fix a bug. What's the last thing in the world you would deliberately do? Try to cause the bug. But it turns out that looking at it 180 degrees is a hugely effective technique. You've got a bug you can't find, try to find all the places where you can cause the bug, deliberately. And sure enough, as you go, oh, well, would you look at that? And then you find it. There's a great example in Edward de Bono's work where he talks about this, juxtaposition of random ideas. There was a group trying to come up with a smoking cessation program, trying to get people to stop smoking. And they're trying, brainstorming, jamming, banging rocks together, trying to find out what to do. So like, well, okay, well, we've got a cigarette. Okay, that's kind of a given. And what's a good common meme for stopping, for a stop sign? Okay, so we got a cigarette and a stop sign. What can we do with that? And as they talked about it and worked with it, they ended up coming up with this system where they'd put a red band around the cigarette, a movable band, so that the smoker could choose sort of how far they were going to go that day. It's like, well, I'm going to smoke up to that line, but no farther. And then the next day move it back. And this became part of their training, part of their program. So you're taking two things that ostensibly have nothing to do with each other, a cigarette and a stop sign, and then evolving that into the solution to the problem they wanted. So we can deliberately produce ideas by searching for relationships between things, even if they're random or impossible things. And this is where you see a lot of the Zen koans, like, what is the sound of one hand clapping? Beats me. It's a stupid question. It makes no sense. But it's actually a great question, because what happens is you face your brain with this question, and it's like, what, are you kidding me? So these R mode processes basically start this ginormous search through all your memories, like, okay, we're looking for something that's going to fit this together. What do we got? And it will dig through all your thoughts, all your memories, and try desperately to come up with something. So it's a good way of engaging that sort of search engine. So, okay, great. We've done all this. We've got all this stuff. It's fermenting in our heads. It's wonderful. Now comes the hard part. Forget the whole thing. Put it out of your mind. You know who was really good at this? Henri Poincaré, the mathematician. Obviously French, which is why I can't pronounce his name. So he'd be working on one of these, incredibly mind-bending, torturous proofs, and he'd be stuck at some point. So he'd say, okay, I knew what the problem was. I'd be stuck at this point in the process, and I would leave what I was doing and go out for a walk in the garden and not think about it, not consciously think about it, but not thinking about it either. Hold it lightly in your brain, in your mind, he said, in your head. It was in French, so I don't know what the translation was. Hold the thought lightly. Don't think about anything else, but don't obsess over that thought. You're just out for a walk. And invariably what would happen is he'd get halfway through his walk and be like, I have an idea. He'd go back, work out that next part of the proof, work for a little while, get stuck in the next part, put stuff down, head out for a walk again. And this worked very well for him. So the key is to not really think about anything else, but don't think about that. Don't focus. Don't let the executive attention network grab hold. Let your mind wander. And maybe that's you're skiing, you're walking, you're bowling, whatever. Something that's not a real focused activity. Because that will allow you better access to the default mode network. And then you get your Eureka moment from good old Archimedes here. Eureka, I have found it, which of course often isn't really Eureka. It's, oh, that's strange. why I thought that was going to be positive. Why is that negative? Something happens like that. But you get this flash of insight. But the only way to get that kind of flash of insight is to let the problem cook for long enough. And so you've got to get better at tolerating the discomfort of the unsolved problem. And this, again, is something I think we find really hard. If there's a problem that needs solving, a solution that needs to be found, we want to jump on that. We want to jump right on that. No, you really don't. And this Harvard psychologist says, the ambiguity inherent in uncertain choices activates the fear center of the brain, thereby disrupting the thinking processes critical to successful innovation. Deadlines, by the way, also panic the brain into failure. That's a topic for another time. So the problem is we're kind of led to believe in society that deciding quickly and with confidence is a good thing. It is not. For any task, when you first start it, you're going to know the least amount about it. Right? I show this slide when I talk about agile methods. Right? The least you know about a project is the day it starts. It may not even have a name yet. You may not even know your teammates. You know nothing about it. First day of class, you know nothing about it. Right? That's the least amount of knowledge. Most amount of knowledge for a software project is when you deliver it and cash the check. That's at the very end. Now you know what it should have been. Now you know what you should have done the first time. You get the most knowledge there, the least then. When do you want to make your big decisions? Back up there? Nope. You want to defer them. But deferring decisions means you have to be uncomfortable. You have to be comfortable with leaving it unsolved and knowing that, yeah, I'm working on it. It's cooking. And let it cook. Finally, as you're working on this, you want this mind map, your doodles, wherever you're sketching your notes on, to be a very open document. This should be like a placemat. You eat dinner over it, you're working on top of it, you're spilling various suspect things on it. Because again, you're sitting there doing something mindless, you're chewing on ramen noodles, and oh, I got an idea. Boop, jot it right down. So you want to leave this very open and easy to access so you can constantly review it and constantly add to it. Then finally, it's time for your idea to go see the light of day and become a little more industrial. You might still stick with a mind map at this point, or you might want to use something that starts getting a little bit more into the computer domain, because at some point you're going to have to produce a document, code, a presentation, something out of it. So it can be very handy to use a wiki. Now you've probably seen Wikipedia often, daily, frequently. And that's a great example of publicly editable web pages, but you can run your own wiki for your own project, for your own thoughts, for your own pet project. The idea being that you make pages for things and link them together. You can also, if you don't want a whole web server, you can use editor modes, Sublime Text and TextMate and Notepad. I don't know about Notepad. Real text editors. You can link pages together with hyperlinks. And this is an important thing, cognitively speaking, because once you have a category for something, you've got a page where you can put that kind of thought, you'll start noticing more things to put there. It's related to the idea of sense tuning, which happens in psychology. It's like if I suddenly said, look for the color red. Okay, these guys have red shirts. There's a red shirt back there. Okay, that's a poor choice here. There's a lot of red shirts here tonight. If it was at least, okay, pale blue. We got any? Or a new model car. Something comes to your attention, and then you start seeing it everywhere. Well, it actually was everywhere before. You just weren't necessarily finding it. But once it becomes important to you, once you have a place to put it, then your brain kind of sets the filters to notice it more. And you'll find more of what you're looking for this way. And the corollary of what I said before, once you start keeping track of good ideas, you'll start noticing more of them. And you get this kind of pile-on effect going. Which leads me to sort of a tangential thought, but a lot of learning and invention ends up being content creation. Here we're creating mind maps, we're creating wikis. If you're studying for a course, you probably have notes, summaries, recipes, cheat sheets, fragments of code, little bits of how-tos, this sort of thing. First time if I go to learn a new programming language, the first thing I do is make a cheat sheet for it as I'm going through and learning it. I had to do that last year, the Elixir language, great functional programming language, very new. I went to make a cheat sheet because there wasn't one. It was a brand new language, so I had to make one. Long story short, now it's the official cheat sheet that you can download from their site, but that's, Even if there's an existing cheat sheet, I want to make my own because it's the things that I want to remember and that I think are important, or the things that I know I'm not going to remember. So there's a lot of that involved in this as well. But that was a tangent. Back to developing your idea. At the end of the day, you actually have to try it. You've got to explain it to people, see what they think about it, do a prototype, actually try it, do something small, let it fail fast. If it's going to fail, learn from that quickly, fix it, do it again. That's how you get it out into the real world. And let me point out, we talk a lot about testing for code, but testing isn't just for code, it's for your ideas and your thoughts and your processes as well. So when you're working through this process and trying to bring your idea out into the light, ask yourself, how do you know? This is great, everyone's going to use it. Really? How do you know that? Oh, no one's using that anymore. Yeah, says who? What would happen if you did? What would happen if you didn't? How specifically? That stops people in their tracks dead. Oh, blah, 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 any internet troll. All right, oh yeah, how specifically? Cut them right off. Says who? That's a fave. I want research links. Show me. So those are the 5 steps. It actually does work. I've done most of them, sometimes all of them at various points. I have people email me. My book that describes this was first published in 2008, which was 7 years ago. I still get people emailing me weekly around the world saying, wow, I tried this stupid sounding crap. It worked. It actually worked for me. So, okay, that's cool. How does this relate to modern software development at all? Does it? Well, I think it does because what we're discovering with software development is that it's an experiment. All the code you write is really just an experiment. It might work, it might not. But we want to try the idea. We want to get feedback from it very quickly with a unit test, with some kind of automated test, with real users looking at it, blah, blah, whatever. We want to have the idea, get feedback from it right then and there, fix it right then and there if it needs to, rinse and repeat. That is the foundation of modern development. Put it a little more precisely, you want feedback from all the activities you do. Coding, meetings, talking with users, whatever, with very short feedback loops. The days are gone where you could wait a month, 6 months, a week for somebody to tell you if they like it. You need to know now. When you get feedback and find out there's a problem, you got to change whatever needs changing. And constantly have, if you're building software, you want working software constantly. You can't afford to have it sit there for 6 weeks while you're trying out something. Try something smaller. Try it now. Get the results now. Do something, get the feedback in real time, in the real world, fix, rinse, and repeat. Because as it turns out, the key to writing software is, ironically, to write software. That's how we answer the tough questions. What architecture should we use? Beats me. We got a couple choices. Let's try 3 prototypes. Let's try one in Java. Let's try one in Elixir. Let's try one in PHP. God help us. Oh, sorry, I said languages, so that wouldn't count. Oh, burn. What tools, what frameworks should we use? I don't know. Let's try a couple. How easy is this one to write in? How quickly can we get a result? Does it actually work? Does it burn and fry itself up? I don't know. How long will it take? Well, I don't know. Let's do it for a week and see how much we get done. Okay, we'll be able to do about that much next week, too. Yeah, I don't know. Let's try it. How much will it cost? Same answer. I don't know. Let's try it. See how far we get. Extrapolate from there. The key to writing software is to write software, to try it, to measure it. These are my 9 books. I got their little pictures up here. Pragmatic Programmer, still one of my faves if you haven't read it. I reread it the other day. It's like, that was a fine book. That was beginner's luck. That was beginner's luck is what that was. My latest one, if you've got a friend who wants to learn Java programming and they're into Minecraft, you can learn simple basic Java programming by writing Minecraft plugins. Yeah, even if you just want to write plugins for fun, it's still a fun book. You just skip over the here's a variable part, but that's great fun. So my Twitter handle, my blog, my email address, you can probably figure out between the two there. And thank you all so much for having me. And we have a few minutes for questions.
So if you have a question, we'll try to get a mic to you. I'll ask our ambassadors to pass the mic around. That way your question is captured for video.
So make it a good one.
Hi. Really enjoyed your speech, or lecture, rather. So a quick question. A lot of the art that I produce is actually all that I produce is digital. And I thought it was interesting that you said you don't want to be at a computer when you're producing your ideas. But creating digital art through Photoshop or Lightroom is inherently artistic, but it's couched in a linear kind of interface. And I just wanted to hear your comments or thoughts on that kind of creative process in a digital medium.
So the question was about creative processes in digital media. Does the interface of the computer limit you or cause problems trying to get better expression? I think it does, at least from my personal experience. I can't paint, I can't work Photoshop, but I do a lot with music. And I find the compositional end of the process gets very difficult. The software can get in your way really easily. So you're sitting there, noodling, banging out an idea on the keyboard, and that's great. And then you go over to the screen, and you got to set up a couple tracks, and you want to put this filter on. And then before you know it, now you're playing engineer for 10 minutes. You got everything. Oh, that's great. Now, what was I doing? So yeah, I find that can be very distracting. And there's ways around that. If you know you're going to sit down and noodle, for instance, it's like get all that set up ahead of time. You just come in and like a tape recorder, just hit record and just go. Or indeed, not even use the computer for that aspect. Just use a simple analog recorder with simple controls. It'd be like sketching on just a simple sketch pad and then going in to Photoshop and doing something real. So it kind of depends on the medium, kind of depends the effect you're after. But I definitely think that in the rawest, most nascent form of the ideas, when they're at the most fragile, you need an environment that's going to be the least distracting and disruptive. And having to fiddle with dialog boxes and numbers and sliders is really not going to enhance anyone's creative juices.
Thanks for your thoughts today. It was wonderful. For those of us who believe our R mode is a little better than the L mode in the way you said it, since there's a lot of demand for developers and coders out there, what are the other career options for computer scientists who necessarily don't want to be managers but stay in computer science? but still don't want to do a lot of coding, don't want to keep writing code. As beginners, what are the career options that you've come across that we can offer?
So the question is, if you're technically minded and you don't want to go into management, but you don't necessarily want to write code the rest of your life either? Let me think about that a second. There are many kind of ancillary positions that involve technology at an interesting level that might not be considered traditional programming or coding. And the fun thing is, and they told this to me 30-some years ago, more than likely, the job that you're going to stick with for most of your career doesn't actually exist right now. It's something that's going to come into existence in the next 2 years, 3 years, something like that. Something will pop up. As technology gets more and more integrated into daily life, you've got a much better chance of doing something that is involved with technology that isn't necessarily, sitting there banging out like a code monkey kind of things. And that might be 3D modeling, something to do with mapping software with Google Glass or whatever it ends up being, since Glass died last week. There's a lot of these kind of ancillary things that can grow out of that. So specifically, I don't know. But I think that you've got a better chance of finding that kind of a job in the next 10 years than you did in the last 10 years. One last question before we hit the juice and cookies or whatever, pepperoni, whatever they got out there.
Thank you very much for the lecture. My question is that sometimes we feel like our ideas are stupid. What kind of ideas should we try?
So the question was, sometimes, possibly all the time, we feel our ideas are in fact stupid. What kind of ideas should we have? Stupid ideas. Let me give you the absolute best example of a stupid idea that I can possibly imagine was just last week in the news. This fellow came up with a website called something like sendglitter.com. Did you hear about this? Right? And the concept was you fill in and you pay your $10, $20, whatever it was. It's like Teleflora or FTD or something, but you're sending an explosive container of glitter to one of your enemies, someone you don't like. And so you fill in the information, and this guy would set up an envelope, and your enemy would get it, open up, and damn glitter everywhere. Very successful. He got hugely backlogged with orders, and he sold the website for, it was millions. I don't remember if it was like 5 million or 30 million. I mean, it was multiple millions of dollars. He sold this stupid, ridiculous idea. I saw a catalog the other day had a USB pet rock. I don't know. I don't know. So I would counter that truly there's no such thing as a stupid idea. There might be unprofitable ideas. There might be infeasible ideas with current technology. I mean, look at the iPad and such, right? Apple had the Newton back in the, what was it, like 85? They had the idea for an iPad in 1985-ish. But the technology wasn't there. They couldn't really do it. So you didn't have the battery life, you didn't have the touch screen, you didn't have the Wi-Fi, you didn't have the sort of capabilities you needed to really make that a viable product. Now you do. And Apple just, their earnings last year were a record for corporations in the history of mankind. Oh, all righty. So they had the idea, but it wasn't time for it back then. But they kept at it. So yeah, ideas might not be viable, but they're not stupid. And it's very, very important to convince yourself that there's not a stupid idea. They're all good ideas, and that you're capable of that one and 50 more just like it. Dr. Carol Dweck, I forget where she was out of. It was either Harvard or someplace fancy like that, did a whole bunch of research on how your beliefs and attitudes about the brain actually cause physical changes in the brain. She did this whole study where she took 2 sets of students, and in one set they believed that brain capacity was fixed, that they would get as smart as they would get, and that's it. You know, maybe they were born smart, maybe they were born dumb, but basically the amount of intellect they had was fixed. She had another group of students who believed that, well, no, you could just, you know, learn infinitely. If you had enough time, you could just study and read and keep learning more and more and just, you know, learn throughout your whole life. And you know where the story is going, right? The people who thought they could learn more statistically did learn more. The people who thought they couldn't didn't. And that is, to me, very interesting, because it's like, whoa, so what you believe can affect your brain? Of course it can. Your brain is a self-modifying machine. What it thinks about itself will be reflected in physical changes in itself. Let that one sink in for a minute. So, you know, I mean, it sounds like one of those motivation posters or demotivation posters, which are much funnier. But truly, if you envision that your mental capacity is greater, it will be, because it's a self-modifying machine. Bang. Thanks, great question.
All right, thank you.
All right, thank you all so much.